Okay, hello everyone. Now today my group is going to present our project TMF 1254 Computer Communication and Network. Okay, next slide is show that our team member. First one is Emmanuel Antawa Anna Sao 104006. Next is Lambert Game Anna Thomas 102653. And next one is Adrian Coley Anna Dominic Nyawai 103332. And next one is Muhammad Kairum Hafiz bin Hafiz Fazila 102717. And next one is me. Last one is Jeffrita William 104515. Okay, now I will go into the part A. Part A is now is introduction. ARQ is stand for automatic repeat queuing. It is an error control strategy used in two-way communication system. There are three different ARQ that we learn. One is store and wait ARQ that send a data frame, then wait for an acknowledgement from receiver, then send another data after receiving acknowledgement for receiver. So the second one is covariant ARQ that is send multiple data packets without waiting for an acknowledgement for each one. We send lost packets and all packets that followed it. And the last ARQ is selective repeat ARQ that's similar to covariant ARQ that retransmit only those packets that are actually lost. Okay, next is flow control ensure that the sender does not overwhelm the receiver by sending too much data quickly. Without proper flow control, receiver may drop packets if the buffer are full, and network congestion increased packet loss, and last one is overall transmission efficiency drop. For the AIQ protocol provide both error control and basic flow control, making them fit that for maintaining data integrity and small communication. Okay, for the next one is experiment state out. Each test case is run for at least 3 times, and we use the average value for communication. So this slide is show that they have ideal network that's for test case one, and the for the test case two is congested network. For this two test case, we can show that in the above we have package loss, acknowledgement loss, and bandwidth latency, timeout, total packets, and window size. There's a compare above two terms. And the next slide is also for the comparison. For the for this slide, we compare the high latency with low timeout interval for the test case 3.1, and test case 3.2 is high latency with high timeout interval. Okay, for the this slide also is experiment set up that now we test the two case is to test case 4.1 is low window size for this, especially for the true ARQ that is go back and selective repeat, and the test case 4.2 is high window size that also is compared to go back and selective repeat. Okay, now we go to performance metric. That is, we have five in the screen. That is throughput, total transmission time, bandwidth utilization, processing overhead, and last one is retransmission count. For the first one, throughput, the actual amount of data successfully transferred from one point to another within a specific time period in megabyte per second. For the second one, there is total transmission time, the total duration between the start of a message transmission and the completion of a delivery at the destination in seconds. For the third one is bandwidth utilization, refer to how efficiency a network is using its available bandwidth for data transfer. For the next one is processing overhead, that refer to the extra computational bundle incurred by device application and protocol when handling without traffic. For the last one is retransmission count. The number of times a data packet is received by the sender after it has not been acknowledged by the receiver within a specific time frame.
Thank you, Jeffrey. Now we're moving on to performance metric test case 1. Our group chose selective repeat as the best RQ because it fully utilized bandwidth, very few retransmission, minimal idle time, and highest throughput. For stop and wait RQ, it has poor bandwidth utilization due to waiting for acknowledge from receiver. For go back end ARQ, it performed well, but unnecessary retransmission slightly reduced efficiency compared to selective repeat ARQ. Next, for performance metric test case 2, we choose selective repeat as the best ARQ because it retransmits only lost packets, conserving bandwidth in a noisy environment. For stop and wait ARQ, it suffers from high retransmission counts and long delays. For go back and RQ, it retransmits entire window on single loss, which is wasting bandwidth and increasing overhead. Next, for performance metric test case 3.1 and 3.2, the best performer is selective repeat RQ because it allows multiple packets in flight, reducing idle time caused by high latency. For stop and wait RQ, it performs worse due to constant waiting between send. And for go back and RQ, it may retransmit many packets unnecessary if one is lost. Lastly, for performance metric test case 4.1 and 4.2, the best ARQ is the selective repeat ARQ because it has larger window boost throughput by keeping the pipeline full. For stop and wait RQ, it has window size of 1 that acts as a baseline, very inefficient under all window scenarios. Between go back and RQ and selective repeat RQ still outperform due to smarter retransmission strategy.
Hello, my name is Lambert Gan. My matrix number is 102653. Moving on to analysis and discussion. For packet loss, stop and wait is very sensitive to packet loss. If a packet or is acknowledged is lost, the sender must wait for the timeout before retransmitting, which significantly reduces throughput. Secondly, for go back end, a single lost packet would cause all subsequent packets in the window to be retransmitted, even if they were correctly received. This increases retransmission count. Finally, for selective repeat, handles packet loss efficiently by only retransmitting the lost packets, maintains better performance under high loss conditions compared to the others. For bandwidth, stop and wait has poor bandwidth utilization, especially at bandwidth network, since it sends one packets and waits. Most of the links will remain idle. For go back end, it will utilize bandwidth better than stop and wait due to pipelining multiple packets in the window. However, waste will occur during retransmission caused by losses. Finally, for selective repeat, best bandwidth utilization among the three because it minimizes retransmission and maximizes pipeline efficiency. For latency, stop and wait, the performance will degrade sharply with higher latency because it waits for acknowledgement after every packet. Thus, transmission time increases. For go back wait and selective repeat, both are more resilient to latency because both allow multiple packets to be in flight, which hides delay and keep the link active. Finally, timeout. For stop and wait, it is a very poorly chosen timeout will drastically affect the performance. So this will cause longer retransmission. For got back and selective repeat, timeout tuning is less critical due to pipelining, but too aggressive timeout still leads to extra retransmission, especially in go back end, since one timeout can cause a burst of retransmissions. In conclusion, stop and wait. The pros are simple and easy to implement. However, the cons, high latency sensitivity and poor bandwidth usage. For Go backend, the pros are it improves throughput with larger windows. However, the cons, it wastes bandwidth on redundant retransmission. Finally, for selective repeats, the pros are it is most efficient in loss and high delay environments. And for the cons, it is more complex, needs more buffer and sequence management. So we can say that stop and wait is only viable for very reliable low latency networks. Go backend works well in moderately reliable networks with some packet loss. And selective repeat offers the best performance overall, especially in real world, imperfect networks with loss or delay.
Hello, my name is Emmanuel Tawa Anak Sawong, metric number 104006. I will continue the presentation for part B. For part B, we will see the network diagram design for NARMI Sendirian Berhad, what technology are used, security considerations, and justification for certain part. This is the network diagram for the NARMI Sendirian Berhad. I will start from the top. The internet will connect to the main router via internet gateway or router with firewall security. From the main router, it connects to two mainframes, which are mainframe office A and mainframe office B. Let us start at mainframe office A. There are three parts that connect to the mainframe office A. The first one is a switch that connects 50 stationary employees' PCs. For the mobile employees who use their personal device, they connect their devices to an access point via switch, which also connected to another switch. Other than that, an access point is connected to the mainframe office A. This access point connects to the guest Wi-Fi in office A. This Wi-Fi router is mainly used for guests only. There is another one that connects to the office A mainframe, which is the printer server. The printer server is also connected by two printers and only the employees can use it. As for Office B, the layout are almost similar to Office A. The difference are the amount of stationary employees, mobile employees, and the printers. We are using star topology as a reference when designing Narmi-Sendirian Berhad network diagram. The reason we chose this topology because the scalability of the company, reliability, and easy to troubleshooting the company system. In the network diagram, there are four virtual local area network known as VLAN. But what is VLAN? VLAN is a method of segmenting a physical network into multiple distinct logical networks. It enables network administrator to partition on a single physical network into isolated broadcast domain. Based on the diagram, there are four VLAN, which are VLAN 10 for Office A, VLAN 20 for Office B, VLAN 30 for guest Wi-Fi, and VLAN 40 for printers.
Hello, my name is Muhammad Khairun Hafiz bin Haris Fazila, matrix number 102717, and I'll be continuing the part B. Continuing on, the technology that we have chosen to use for the network diagram is Cat6 Ethernet cabling for its high performance and cost efficiency, Wi-Fi 6 APS to accommodate multiple concurrent connections with minimal latency, VLANs for logical segmentation, as well as saving costs and enhancing security. For the router, we have chosen an enterprise-grade router with integrated cloud-managed Wi-Fi and QoS settings. Lastly, we chose a 24 or 48 port gigabit Ethernet switches, which we believe to be sufficient in fulfilling the connection capacity whilst providing overhead for potential expansions. In regards to Wi-Fi security considerations, we chose WPA2 PSK for guests due to simpler logins and TOS, and WPA3 for staff SSID due to their importance and security risk. For firewall rules, all devices connected to VLAN 30, which were set for guest devices, are prevented from accessing the general hub, thus preventing guest access to internal company resources or company devices. These are additional information on why specifically Cat6 Ethernet cabling, Wi-Fi 6 APS, and firewall security hardware was chosen for our network diagram. And that is the end of our presentation. Thank you.